Hello students, today we'll study part B, stoichiometry. What is stoichiometry? It is the study of quantitative relationships of ratios between two or more substances undergoing a physical change or a chemical change. The word derives from the Greek word stoichion meaning element and metron meaning to measure. First we'll study about percentage composition. This is already I've studied in your 9th standard. So what is percentage composition? It's the percentage by weight of each element present in the compound. How it is calculated? Composition is equal to weight of the element in one molecule of the compound multiplied by 100 and divided by gram molecular weight of the compound. That is molecular weight of the compound expressed in grams. Now problems based on percentage composition. Calculate the percentage by weight of aluminium in aluminium nitride. First calculate the molecular mass of aluminium nitride. Atomic weight of aluminium is 27 and that of nitrogen is 14. So by adding 2 you get 41 grams, that is the molecular mass of aluminium. Now find the percentage of aluminium in aluminium nitride, which is equal to mass of aluminium into 100 by that of molecular mass of aluminium nitride, which is equal to 65.85%. One more problem, the second one. Calculate the percentage of iron in potassium ferricyanide. Now, atomic weights of all the elements are given. You calculate the molecular mass of potassium ferricyanide by substituting the values, atomic weights. So we get 329 grams. There are 3 atoms of potassium. So 3 into 39 plus 1 atom of iron, 56 plus 6 of C and N. So 6 into 12 plus 14. So which is equal to 329 grams. So you have to calculate only the percentage of iron. So iron's atomic weight is 56 into 100 by the molecular mass of potassium ferricyanide, which will give you 17.02%. The next one, calculate the percentage of water crystallization in hydrated copper sulfate. Formula CuSO4.5H2O. So atomic weights are given. Calculate the molecular mass of hydrated copper sulfate, which will be equal to 249.5 grams. Only the weight of water of crystallization is 90. That is 5 into 2 into 1 is 2 plus 16. That is, you get 18 into 5 will be 90 grams. So you have to calculate the percentage of water crystallization. So water of crystallization is 90 grams into 100 by the total mass of the molecular mass of copper sulfate. That will be 249.5. So you get 36.07% water of crystallization. So the next is empirical formula. What is the empirical formula? It is the formula of a compound which shows the simplest whole number ratio between the atoms of the element in the compound. For example, the molecular formula of glucose is C6H12O6. The simplest whole number ratio will be CH2O. So that is the simplest ratio. That is called as the empirical formula. So how to determine or find the empirical formula of a compound? So here are the steps given to find the empirical formula. You just read the steps. You may not understand or it may not be very clear. As you do the problem, work on the problem, it becomes very easier. So what is the first step? Write down the percentage composition and the atomic weight of each element present in the given compound. Then divide the percentage composition of each element by its atomic weight. So you get a ratio, gives the number of atoms of each element or the relative number of atoms in the compound. So for example, if you take sodium, percentage composition given here is 29.1%. Divide by the atomic weight of sodium, that is 23. So then you will get the ratio, number of atoms of each element. Then the third step, select the smallest ratio. So select the smallest ratio among all these elements which is given there and divide the remaining ratio by it to give the simplest ratio of atoms. Then if the simplest ratio is not a whole number, suppose if it is not 1, 2 or 3 or it is in decimals, then multiply each ratio by the smallest integer so that a whole number ratio is obtained. Then write the empirical formula showing the atoms, elements in the proper simple ratio of whole numbers. Then calculate the molecular formula by applying the formula given. Molecular formula is equal to empirical formula into n. N is an integer which has to be calculated. So suppose the empirical formula is CHO2 and N is equal to 2, then your molecular formula will be equal to C2H2 and O4. So just by reading the steps, you may not understand or it may not be clear to you. So let's move on to the working of the problems. The problems based on empirical formula. A compound contains 87.5% by mass of nitrogen and 12.5% by mass of hydrogen. Determine the empirical formula of this compound. So this was given in the year 1996. So first step, step 1. Write down the percentage composition and atomic weight of nitrogen and hydrogen. So this column is very important. You have to draw this column. First column is element. So what are the elements given? N and H. Write only the symbol, not the molecular formula. So nitrogen, the percentage composition given is 87.5%. And hydrogen's percentage component is given as 12.5%. So the next is write down its atomic weight, which also will be given to you. So atomic weight of nitrogen is 14 and that of hydrogen is 1. Now find the relative number of atoms. So you have to divide percentage composition by the atomic weight. 87.5 divided by 14 equal to 6.25. And 12.5 divided by 1 will be equal to 12.5. Now among these two, select the smallest one. 6.25 is the smallest number. So divide both by the same number. So 6.25 divided to get the simplest ratio. 6.25 divided by 6.25 is equal to 1. Then 12.25 divided by 6.25 will be equal to 2. So therefore empirical formula is equal to N is equal to 1 and H equal to 2. So NH2. 1 we don't write it. So it is NH2. So this is the way empirical formula is calculated. So if you go by stepwise, it looks difficult. But when you draw the columns and just go on writing what is given, the data, and then you calculate, it is very easy to calculate empirical formula. One more problem. Compound of sodium, sulfur and oxygen has the following percentage composition. So nitrogen, sodium is 29.11%, sulfur is 40.51%, oxygen is 30.38%. Find the empirical formula. So oxygen's atomic weight is 16, sodium is 23, sulfur is 32. All this will be given in the problem. Now draw the column which consists of 5, 1, 2, 3, 4 columns, 5 columns. So the first column is element. Write down the symbol. Sodium is Na, sulfur is S, oxygen O. Then write the percentage composition which is given in the problem. Copy the same. Then the atomic weight which is also given. Now find the relative number of atoms. That is, divide the percentage composition by atomic weight. 29.11 divided by 23 is equal to 1.266. Then 40.51 divided by 32 is 1.266. 30.38 divided by 16 is equal to 1.899. So among the three, 1.266 is the smallest. Divide all the three relative number of atoms by the smallest number. So 1.26 divided by 1.266 is equal to 1. Then similarly, second one also will be equal to 1. But the third one, that is oxygen, the relative number of atoms is 1.898 divided by 1.266 is equal to 1.5. So it is not a whole number. So when you get 1.5, you have to convert this into a whole number by multiplying by the smallest number, that is 2. So multiply all the three, not only oxygen, you have to multiply sulfur and sodium also by 2. So by multiplying by 2, you get 1 into 2 is 2, that is sodium. Sulfur is also 2. Now 1.5 into 2 will be equal to 3. So what is the empirical formula? Na is 2, S is 2, O is 3. So Na2, S2, O3. So this is how you get the empirical formula. Now what you have to remember here, in case the simplest ratio is not a whole number, then if it is 1.5, you will multiply by the smallest number 2, all the elements present in that compound. In case if this decimal is more than 5.6789 or something like that, then you'll have to take it to the higher number. If it is less than 5, like 1.1, 2, 3 or 4, then you take it to the lower side. But if it is exactly 1.5, then you will have to multiply by the smallest number, that is 2. all the elements present. So that's how you get the whole number and the empirical formula. The next example, calculate the empirical formula of the compound having 37.6% sodium, 23.1% silicon and 39.3% oxygen. Work to 2 decimals. So if it is given, you can follow this. If not also, you can work up to 2 decimals. These are the atomic weights given. So first column is element. Copy down all the elements. Na, sodium, silicon, Si and oxygen. The symbols you write. Then write the percentage composition given in the problem. Then write the atomic weight. Then calculate the relative number of atoms by dividing percentage composition by atomic weight. So 37.6 divided by 23 is 1.63 and 23.1 divided by 28 is 0.825. 39.3 divided by 16 is 2.45. Now find the smallest number among these three. Smallest number will be 0.825. So divide all the three relative number of atoms by this number. So first one 1.63 divided by 0.825 is equal to 1.97. So after the point it is 9 not 5. It is more than 5. So you can equal it to the higher side, that is 2, equal to 2. Then 0.825 divided by 0.825 will be 1. Then the third one, that is of oxygen, 2.45 divided by 0.825 is 2.97. Here again you can bring it to the higher side, that is equal to 3. So Na is 2, Si is 1 and O is 3. So empirical formula is Na2SiO3. Then one more example. Determine the empirical formula of a compound whose composition by mass is 42% nitrogen, 48% oxygen and 9% hydrogen. Atomic weights are given. Write down the elements. NOH, nitrogen, oxygen, hydrogen. Percentage composition is 42%, 48% and 9%. Atomic weight is nitrogen 14, oxygen 16, hydrogen 1. Now find the relative number of atoms by dividing percentage composition by atomic weight. So nitrogen you get 3, oxygen is equal to 3, hydrogen equal to 3, relative number of atoms. Now choose the smallest number among the 3. 3 is the smallest. Divide by 3 by all the others. So 3 by 3 equals 1, that is nitrogen. Again 3 by 3 equals to 1, that is oxygen. 9 by 3 is equal to 3, that is hydrogen. So NOH3. Empirical formula is NOH3. I hope you understand, and it is very easy. There is no need for you to follow the steps. If you read the step, you find it difficult. But once you start calculating, drawing this table with 5 columns, it is very easy to calculate. Then one more problem. Determine the empirical formula of a compound containing 47.9% potassium, 5.5% beryllium and 46.6% fluorine by mass. Atomic weights are given. Work to 1 decimal place. So 1 decimal is enough here. Now write down the elements. Potassium is K, beryllium is B, fluorine is F. Percentage compositions are given. Note down the percentage composition. Atomic weight is also given. Note down that. Then calculate the relative number of atoms. Percentage of potassium is 47.9 divided by atomic weight 39, which is equal to 1.2. Then beryllium's percentage composition is 5.5 divided by atomic weight 9, which is equal to 0.6. Then percentage composition of fluorine is 46.6 divided by atomic weight 19, which is equal to 2.4. Choose the smallest number. 0.6 is the smallest number, and divide all the other three relative number of atoms by the same number. So 1.2 divided by 0.6 is equal to 2. 0.6 divided by 0.6 is equal to 1. Then 2.4 divided by 0.6 is equal to 4. So that is K is 2, B is 1 and F is 4. So empirical formula is K2BeF4. Next we'll study about molecular formula. So once you calculate empirical formula, only then you can calculate molecular formula. So first you have to calculate empirical formula. So what is molecular formula? Molecular formula is the chemical formula which represents the actual number of atoms of each element present in the molecule of a compound. So, molecular formula of glucose is C6H12O6. So, actual number of atoms it will show in the molecular formula. Whereas in the empirical formula, it just shows the simplest number of elements. That is, glucose is C6H12O6 molecular formula. Empirical formula will be CH2. Now, determine the molecular formula of a compound from its empirical formula. So, how to calculate? The compositions are given of carbon, hydrogen and oxygen. Vapor density of the compound is given, which is equal to 45, and atomic weight also is given. The empirical formula of the compound is determined by explain. Already what we have done, the same we have to calculate the empirical formula. So first step is to find the empirical formula, and from that empirical formula you will find the empirical formula weight. So empirical formula of the above compound was calculated to be, suppose this is calculated and it was found to be CHO2. So its empirical formula weight will be C is equal to 12 plus H is equal to 1 plus 2 into 16 oxygen. So it will be equal to 45. Empirical formula is CHO2. Empirical formula weight is equal to 45. The second step, note the molecular weight or calculate it from the vapor density. Suppose molecular weight is not given, you have to calculate, or you can get it from the vapor density, because molecular weight is equal to 2 into vapor density. So vapor density is given 45 here. Therefore, molecular weight is 2 into vapor density, which is equal to 90. The third step, determine the value of n, an integer, by applying the formula. So you have to find out what is n. So how it is done? A molecular weight is equal to n into empirical formula, or n is equal to molecular weight divided by empirical formula weight. So here we know molecular weight is equal to 90, empirical formula weight is 45. So if you divide these, you get 2. N is equal to. Now problems based on molecular formula. The compound A has the following percentage composition by mass. Carbon is 26.7%, oxygen is 71.1%, and hydrogen is 2.2%. Note down the elements, their symbol, and then the percentage composition. Now write down the atomic weight given. Carbon is 12, oxygen is 16, hydrogen is 1. Now from this, find out the relative number of atoms. So divide the percentage composition by atomic weight, you get the relative number of atoms. Carbon is 2.2, oxygen is 4.4, and hydrogen is 2.2. Select the smallest number and divide. 2.2 is the smallest. So 2.2 by 2.2 equals 1. Carbon is 1. 4.4 divided by 2.2 is equal to 2. So oxygen is 2. Then 2.2 divided by 2.2 is equal to 1. Hydrogen is 1. So empirical formula is equal to C1H1O2. C1H1O2. So though we have written COH, we normally write it as CH and O. So CHO2. Empirical formula weight is equal to, calculate the empirical formula. Carbon is 12 plus oxygen is 1 plus 2 into 16 equal to 45. So molecular mass is equal to 90, which is given in the formula. Relative molecular mass is 90. So molecular formula is equal to N into empirical formula. So molecular formula is 2 into CHO2. So we know that N is calculated by dividing molecular mass by empirical formula mass, that is 90 divided by 42. Empirical formula mass is here, molecular mass is given in the problem 90. So you get N equals 2. So molecular formula is N into empirical formula. So you know empirical formula CHO2 into 2 will be C2H2O4. Second problem, an organic compound with vapor density 94 contains carbon, hydrogen, bromine. Find the molecular formula. So here are the atomic weights given. Note down the, draw the column. Element is carbon, hydrogen, bromine. Percentage is 12.67, 2.13, 85.11. Atomic weight is 12, 1 and 80. Atomic weight and percentage composition are given in the problem. Now calculate the percentage of atomic, that is the relative number of atoms, by dividing percentage composition by atomic weight. So carbon is 1.06, hydrogen is 2.13, bromine is 1.06. Select the smallest number, 1.06, simplest whole number ratio. That is 1.06 divided by 1.06 equal to 1. 2.13 divided by 1.06 is 2. Again 1.06 divided by 1.06 is 1. So BRC equals 1, H equals 2, Br equals 1. Empirical formula is CH2Br. From this you have to calculate the molecular formula. For this, first calculate the empirical formula mass. So that is C is 12 plus 1 into 2 is hydrogen plus 8 is bromine is equal to 94. So now you know the empirical formula mass. So you have to calculate the N. N equals to molecular mass. Molecular mass is 188 divided by empirical formula mass, which is equal to 94. So how do you get molecular mass? You have to substitute the values and get this 188. Then here it is given already because vapor density is given as 94. So molecular weight will be 2 into vapor density. So that is equal to 188. If it's not given, then molecular formula, if it's given, from that you can calculate. Now molecular formula is equal to N into empirical formula. So N is calculated to be 2. And we know empirical formula is CH2Br. So it is C2H4Br2. C2H4Br2 is the molecular formula of this given compound. The next problem is a gaseous compound of nitrogen and hydrogen contain 12.5% of hydrogen by mass. Find the molecular formula of the compound if its relative molecular mass is 32. So you have two elements, hydrogen, nitrogen. The percentage composition 12.5 and 87.5. Atomic weight of hydrogen is 1, that of nitrogen is 14. So calculate the relative number of atoms by dividing the percentage composition by atomic weight. So 12.5 divided by 1 is 12.5. 87.5 divided by 14 is 6.25. And from that you have to calculate the simplest ratio. Choose the smallest number, 6.25 is the smallest, divide by both. So 12.5 divided by 6.25 is equal to 2 and 6.25 divided by 6.25 is equal to 1. So H is 2, whole number ratio is 2 and 1, H is 2 and N is 1. So empirical formula is NH2. And calculate the mass, empirical formula mass from this, which will be equal to 14 plus 2 into 1 equals 16. Now molecular mass is given equal to 32. So N equal to molecular mass by empirical formula mass. So 32 divided by 16 is 2. So N we got it as 2. Molecular formula is N into empirical formula. So you have to remember all these formulas, how to calculate molecular formula, how to calculate N. So N into empirical formula, that is 2 into NH2 will be equal to N2H4. Then one more problem. A compound on analysis gave the following percentage composition, that is sodium is 14.31 and sulfur 9.97, hydrogen 6.22, oxygen 69.5. Atomic mass of sodium 23, sulfur 32, hydrogen 1, oxygen 16. Now divide this and get the relative number of atoms. So sodium is found to be 0.62, sulfur 0.31, hydrogen 6.22, oxygen 4.34. Choose the smallest number. 0.31 is the smallest. Divide all the others by the same. So 0.62 divided by 0.31 is 2, that is sodium, and 0.31 by 0.31 equal to 1, that is sulfur. 6.22 divided by 0.31 equals to 20, that is hydrogen, and 4.34 divided by 0.31 equals to 14. So the empirical formula of the compound is Na2SH20O14. Calculate the empirical formula mass of this compound, which is found to be 322. Molecular mass is already given in the problem, which is found to be 322. So N equals molecular mass divided by empirical formula mass. Both are 322, so you get 1. So molecular mass will be equal to empirical formula mass because N is 1 only. Otherwise, it is N into empirical formula. So N is 1, therefore empirical formula and molecular formula remains the same. Now, since you have to read the question, calculate the molecular formula of the compound on the assumption that all the hydrogen in the compound is present is in combination with oxygen as water of crystallization. So that's the reason why now what we have to see this, there are 20 atoms of hydrogen, but oxygen and hydrogen are together to form water of crystallization. So you get 10 H2O, and 4 oxygen which is remaining will combine with Na2SO4. So that's how you get the formula Na2SO4 dot 10H2O. Since all the hydrogen atoms are present in combination with the oxygen as water of crystallization, therefore all the 20 hydrogen atoms must be combined with 10 atoms of oxygen to form 10 molecules of water of crystallization. Thus, only 4 atoms of oxygen are present with the compound. Hence, the molecular formula will be Na2SO4 dot 10H2O. The last problem. A metal M forms a volatile chloride containing 65.5% chlorine. If the density of chloride relative to hydrogen is 16.2 162.5, find the molecular formula of the chloride. M is 56, Cl is 35.5. First, calculate the empirical formula. Write down the element, percentage composition, atomic weight, relative number of atoms. By dividing these two, you get the relative number of atoms. Choose the smallest number, divide by the same, you get the simplest ratio. So you get the empirical formula. M is 1, Cl is 3. So that is MCl3. Empirical formula weight you calculate from this. So M is 56 plus Cl is 35.5. So there are 3. So 3 into 35.5 will be 162.5. Molecular mass is 2 into vapor density. So vapor density is given in the problem. So you can write 2 into 162.5 equals to 325. Now calculate N, that is molecular mass by empirical formula mass. Molecular mass is 325. You have calculated here. And empirical formula also calculated to be 162.5. If you divide, you get 2. So N equals 2. Molecular formula is N into empirical formula, that is 2 into MCl3 will be M2Cl6. So with this we complete stoichiometry and mole concept and stoichiometry. So we'll have to work out a number of problems, only then it will become easy for you to understand. All the problems from the textbook, that is the additional questions, unit test paper and board papers have to be solved. We'll do one by one. If you have any doubt in what we have done today, we can get it clarified during our online classes. Thank you, children.